Okay, in this question, we are asked how long will it take for the concentration of A to decrease from 1.25 molar to 0.205 molar for the second order reaction reactant A becoming products. And we're given the rate constant, 1.52 inverse molar inverse minute. One thing to point out about this question, this is one of those questions that it will change one of the numbers. So this is what I got in my problem set, but your question 31 might have a different number here, but the solution is going to be the same method. Okay, so the other thing to recognize here is that once again we're working with integrated rate laws because it's asking us something about time. How long will it take? And it gives us concentrations. So those are the clues that tell us we'll be working with integrated rate laws. And the question is, well, which one do I use? Remember, you don't need to memorize the integrated rate laws. They're given to you on your equation sheet, but you need to know which one to use and how to use them. So, in this problem statement, we're told that it is a second order reaction. So, I'm going to use the integrated rate law for second order reactions, which is right here. 1 over the concentration of a reactant at some time is equal to the rate constant times time plus 1 over the initial reactant concentration. So let me just write that down again on this sheet. So 1 over the reactant concentration at some time is equal to the rate constant times time plus 1 over the initial reactant concentration. All right? So what we're asked to solve for is how long it will take. We want to know that time. That's the variable that we need to isolate. So I'm going to subtract 1 over the initial R concentration from both sides, and I'm going to divide by the rate constant. So let me just rewrite that and rearrange it. So time is going to be 1 over the reactant concentration at some time minus 1 over the initial reactant concentration. All of that divided by the rate constant. So now I'm just ready to plug and chug. I'm given all the numbers that I need to solve this. So let's just go ahead and do that. Time is 1 over the concentration at a certain point in time, in my case 0.205 molar. Okay? Now remember, that's going to be a different number for you because it's one of those problems that it can change one of the data points in the question for every individual. Subtract from that 1 over the initial reactant concentration, which was 1.25 molar. Okay, and we're going to divide that by the rate constant, which is 1.52 inverse molar inverse minute. Okay, so that's just a matter of doing the math. So we plug all this into our calculator, turn that on, clear that out. Give me some room here. So we go 1 divided by 0.205, enter, and subtract from that 1 divided by 1.25, enter, and we're going to divide that by the 1.52. There you go. So it should be 2.68 minutes. If you look at the units, it rearranges and you get your units of minutes.